my hope today is to give you a non-technical presentation on machine learning. So this is for you folks out there who don't have a lot of background in it. If you want to talk to me about Kaggle scores and about the best way to prune your hidden layers in a neural network, and if you want to talk about rule induction versus SVM models, we can talk shop another time. But you're not going to get anything out of this lecture, this conversation, if that's what you're looking for. So I'm going to try to stay really non-technical and try not to scare anybody. Me, born and raised in Vancouver, Washington. That's where I am today. Father of 3 personality plus kids, and I got a preschooler, an elementary schooler, and a middle schooler, and they're all home today because we have a snow day unexpectedly, and so it's loud and chaotic here instead of quiet and peaceful. I play lots of instruments in a rock band. Nobody likes us, so you don't have to listen to it. But that's my passion. My background is a bachelor's in chemical engineering and an MBA in data science, and I've been a data scientist and analyst for about 20 years. I've been with Marquam since 2018, and over that 20 years, I have sporadically done machine learning, on and off, sometimes and sometimes not. And let's talk about why I have only sporadically done machine learning, because I think that's a good lead into what machine learning does for you. Like most companies, we learn in Psych 101, Maslow's hierarchy of needs. Companies have a hierarchy of needs too. We start out with our foundational needs, where we need to spend most of our time, and get up to some things that if we're performing well, we can handle. And I would say that a company's data needs start out with some really basic questions. How much money did we make? You gotta make sure the investors know that. When we get a little more sophisticated, we can say, well, what products or what locations, where are we making our money? You can start to forecast how much money will we make next year. And then once we have those questions answered, we can get into these real esoteric questions like, which of our customers will purchase next? Or how can our company make more money? Or what's going to happen next? But those esoteric questions can only be answered once we have these fundamental basic ones answered. So it's a move from descriptive statistics to predictive statistics. And I can tell you that because I've worked in mostly small to medium-sized companies my whole life, we've spent a lot of time on descriptive statistics and not very much time on predictive. And that's as it should be, because it's what the company needs to exist and survive. So the descriptive statistics, things like sum and count, how many accounts do we have? How much money did we make? We get a little more sophisticated. We start asking things like mean and median. What's our median customer look like? And then we get into forecasting, and usually your CFO has these pretty well handled. Things like simple linear regression, moving averages, ARIMA modeling. And then you get into some things that are a little more complex: multiple linear regression, logistic regression, rule induction and decision trees, Bayesian statistics, neural networks. And all of this stuff up here in the top falls under the aegis of machine learning. And that is as technical as I'm going to get talking about those models. What is machine learning? Microsoft defines it as the process of using mathematical models of data to help a computer learn without direct instruction. Meaning we use algorithms to identify patterns within the data, and those patterns are used to create a data model that can make predictions. Okay, still kind of fuzzy here. Here's a better description. Seth Juarez from Microsoft says machine learning is lazy programming. We'll talk about what that means. In a typical programming, you have your input data, and you run it through an algorithm, and you spend a lot of time writing that algorithm so that it does exactly what you want to the data. I'm being really vague here, but once you have that algorithm and you run your data through that algorithm, you get your answers. Machine learning, we can't be bothered making the algorithm, so we're just going to take our answers, and we're going to take our data, and we're going to run it through a machine learning model, and the computer is going to come up with the algorithm. It's going to say, I think you did this to get these answers. And then we use that algorithm in the future to run more data through to get more answers. So that's the difference between machine learning and traditional programming. The deal with machine learning is it usually requires a lot of data to work well. And of course, the follow-up question is, well, how much data, Alex? And that's when we get to a lot of, well, it depends on what you have and what kind of models and stuff like that. So we'll just suffice it here to say it requires a lot of data. Quick vocabulary check. We talk about all these terms: artificial intelligence, machine learning, deep learning. And there's quite a bit of overlap and quite a bit of similarity between the three. So let's kind of talk about them. Artificial intelligence, this is another Microsoft definition: the capability of a computer system to mimic human cognitive functions. It says through AI, a computer system uses math and logic to simulate the reasoning that people use. So artificial intelligence is trying to get a machine to think like a human. Machine learning is a very big subset of that. It's the application of AI. It's using mathematical models to help a computer learn without direct instruction, like we talked about, the lazy programming. And a buzzword you hear a lot recently is deep learning. Deep learning is a type of machine learning. It's certain types of models within machine learning. And I'm not going to get into defining that because deep learning is sometimes the type of model you need and sometimes not. And it's a tool we have in our tool belt. So all three of these, artificial intelligence, machine learning, deep learning, in a lot of ways are interchangeable. Before we go any further, I want to assure you that machine learning is not here to try to replace you in your job. The robots are not coming after your job. Not unless you're working as a checkout person at Home Depot. You ever try to find a real checkout person at Home Depot? Anyway, machine learning is more of a way to extend your capabilities and help you do more. You are in the driver's seat. You are making the decisions, and machine learning is going to help you get there. But what is it good for? It's awful complicated. Well, ultimately, we are in the industry of being knowledge workers. And when you boil down to what we do and what we get paid for, we are paid to make decisions for our respective companies. And so machine learning is going to enable us to make those decisions better. So better or faster. So think about, what do you wish you knew more accurately, easier, or earlier? And let's see if we can use machine learning to help you make those decisions. I'm going to take a bit to talk about some of the folks that we've worked with in the past with Marquam, and talk about the projects we've worked on recently. You're going to use the word predict a lot because that's a lot of times what we're doing. Worked with Enlight. They're a laser manufacturer, and I feel like it's so futuristic. I feel like we robots and laser beams and stuff like that. Keep doing the Dr. Evil laser. Anyway, we worked with Enlight to predict manufacturing error. We got their telemetry, the information from their factory, and actually factories of their clients using these Enlight lasers. And we were looking at the conditions in which those lasers failed and tried to predict under what conditions are these lasers going to need replacement, under what conditions should they not operate, that sort of thing. Interesting stuff, predicting manufacturing error. Very similar one with NACE, North American Energy Solutions. They have power generation turbines, and we're trying to predict output and where, trying to identify when their turbines needed to be taken down for service how often and when, as the turbines age, they output less power, and so how to balance when to take the turbines down for service, knowing that take them down for service means you're not generating electricity. So interesting stuff. This one I think was my favorite. Worked with the Portland Trail Blazers on ticket revenue. So as you see in their home arena, the Rose Garden, I can't remember who's sponsored it these days, but it's the Rose Garden. About half the tickets are season tickets, and the other half of the tickets are the kind you walk up to the box office and buy, or you buy online or something like that. And tried to predict which games are going to sell at which price points and which seats. It was really interesting. And yes, when Steph Curry or LeBron comes to town, the seats sell out more. But we were able to find the kind of a consumer price elasticity on those seats, and we're able to help them maximize ticket revenue so that they could price them to sell more. Really interesting. Kind of priced myself out of ever getting Blazer tickets again, though. I'm one of those fair weather NBA fans. I'd like to go, but $100 tickets are a little too much for me. I can watch on the TV. Tillamook, if you're on the West Coast like me, that's where they make the cheese. And we worked with Tillamook in their supply chain to try to predict inventory outages within stores. And we were able to, with a relatively good degree of accuracy, predict which stores would be out of which products with a 2-week lead time. So we know, based on the amount of sales that have been going on and the amount of blocks in transit and in the supply chain, who's going to be out in the next 2 weeks. It was fascinating because we tried to extend that to 3 weeks, and we found that we could not, with any degree of accuracy, predict which stores were going to be out within 3 weeks because their supply chain was designed in such a way to self-correct those errors. So by 3 weeks out, all of the hitches in supply were taken care of. So anyway, fascinating stuff. Readiness systems. Oh, this was a fun one. So this is a company that sells these defibrillators, and they put them in different workplaces or retail locations. I think there's always one in the mall food court, right? And each of these defibrillators has a battery pack and will eventually run out of charge and need to be recharged. Well, Readiness Systems wanted to be able to identify which of their defibrillators were out of batteries, but couldn't connect them to the Internet of Things. So they did the next best thing. They pointed a webcam at each of them. And we ran a image classification modeling to try to identify, okay, this one's got a green light on, this one's battery pack is good, this one's got a red light on, this battery pack is bad, or somebody stole the webcam and they're pointing at their cat. And so that was fun, image classification, and it ended up being pretty accurate. Legacy Health. This was a fun project. So I did 2 projects with Legacy. One of them was their IT department wanted to know when they could take their systems down for maintenance. And Legacy runs hospitals, including ERs, and the ERs run 24/7, 365. So there's no time they're closed that they can take the hospital data systems down. So we ended up using some really fancy R-based seasonality time series analysis to try to identify when the hospitals are the most busy and the least busy. And we threw in all sorts of data into that. The fun part is that, the hospitals, anecdotally, they say, oh, the ER is always fullest on the full moon or something like that. So we actually used, among other things, lunar phase, day of the month, day of the week, time, and all sorts of things into this model. And it simplified down to a really simple model where their patterns are mostly just weekly. And so the answer to when we could schedule IT downtime is generally any Sunday night, Monday morning between 12 a.m. and 4 a.m. So there was a whole bunch of complexity that went into the model, but it ended up simplifying out and becoming a pretty simple behavior pattern. So anyway, that was fantastic. I really like doing that. The other one I worked with Legacy was predicting patient-doctor outcomes. The idea of when a patient has a long-term stay, they're seen by several doctors. How do we credit that patient's stay to a given doctor so we can say this doctor has only 20% of their patients return, where this doctor 60% of their patients return, or we have mortality or things like that. And that was fascinating, but it ended up getting mired in some intra-doctor politics and stuff like that. Nobody wanted to be responsible for when a patient died or when a patient came back to the hospital sick again. Anyway, you get me talking about these things and I just keep going and going. So I got to move on. Now that we've looked at some examples, there are kind of three main categories of machine learning: regression, classification, and clustering, asking questions of how many, what category, and in what group. Regression is pretty straightforward. You know, what will revenue be in Q3 for Latin America, product X? How many salespeople will we have at the end of Q4? That's all pretty basic stuff. I'm going to skip over to clustering. Clustering is often used in marketing. How do we cluster our customer base? Are there groups of customers that behave different than others? That sort of thing. Classification is probably the biggest one. And it's not just like that image sample where we're looking at green light on, red light on, but there's also things like what's the probability of this or that? What's the probability of a customer to purchase this insurance package? What's the probability of a customer to leave us? That sort of thing. So that's kind of the three main categories. And as far as software tools, there are many software tools out there to do machine learning. These are the ones that I'm focused on currently, and they're not any better or any worse than the other things that are out there. But Azure Machine Learning Studio from Microsoft, obviously Power BI, Microsoft's product, has an auto machine learning function. If you get your data just right and can feed it in there, it'll do some machine learning for you without much control. It just kind of spits out some answers. I'm fluent in R and can write things in R. I'm learning Python, although I keep switching back to R. And then this Azure Custom Vision, which is what we use for the image processing. The point with this is not that I know so many tools or anything like that. The point with this is it's always good to use the right tool for the right job. And we have enough that we can bring the right sized wrench to loosen whatever nut we need to loosen. So here's the question that I think a lot of people get stuck on. How do I get started? So we know we want to do some machine learning, but where do we even begin? The process that I've learned and used is called the Cross-Industry Standard Process for Data Mining, CRISP-DM. And it is one of several processes that you can use for machine learning. This just happens to be the one that I use. And the idea here is you start with a business understanding. You start with, okay, what do we do and what are we trying to accomplish? From there, we move into the data and get really deep in understanding the data that we have. Then we're able to prepare the data for modeling, evaluate those models, and deploy those models. And that's a pretty straightforward process. But the important part of this is that it is not a linear process. This is a very circular and iterative process, where with each step, we learn some things, we can move on to the next step, and then maybe we have some more questions we need to return. And so the idea is you're not just done when you've created your first model. When you've created your first model, you know some things, and you can probably do better next time. And so with each step, we gain more understanding of what's in our data and how we can help our business. At this point, I think I need to point out that this is a scientific process, and sometimes the answer is no. Working with Tillamook, we tried to predict supply chain outages 3 weeks out, and the answer was we can't because you don't have them. Quite often the answer is we don't have the right type or we don't have enough data. And even that is knowledge you didn't have before. So going through this process really kind of helps you gain that understanding about what data you have and how you can use it. Back to the process. These 3 steps, business understanding, data preparation, is where I think that I think that experience counts. I think that it's really the hardest part for data scientists. It's just the hardest to get this flywheel going and get understanding the data and get started on the project. But if any of you have looked into machine learning online, 98% of the training material is how to build a model and evaluate it, which is fine. That's good information to know. But the hardest part is getting started to the point where you even have that data set to model. In fact, in my experience, over 50% of the process, the time in the process is in these 2 steps alone. Data understanding and data prep. And that's kind of where experience helps out. As you're building machine learning models, it's important to realize that robots think and act differently from us. And yes, I'm anthropomorphizing my machine learning models into a robot a little. That's fine. But these Daleks can't get up the stairs. And it's sometimes it helps to know how the machines think and identify common problems that they're going to come up with as you're building these machine learning models, common obstacles. And the first common obstacle that we seem to invariably run into when building machine learning models is sparse or dirty data. Either there's a hole in the data with there's things we don't have, or things are entered poorly, or we're missing things, or it's just we can't trust it. So really getting into the data, understanding it, cleaning it is very important. Another common obstacle is using improper data. I can't be overdrawn because I still have checks. The idea is sometimes data just does not provide the predictive value that you think it might. A good example here is NACE, North American Energy Solutions. I told you about the power turbine project we were working on. We went through our first pass of creating a model with them, and we came up with this model that had a 99.9% correlation rate. We said, yes, that's really good. No, wait, what's going on? And we found that some of the telemetry data they were giving us was not an input to the power generation turbine. It actually was an output. It was the position of the exhaust flaps on the turbine. And when the turbine was generating a lot of power, the exhaust flaps were open. When the turbine was generating less power, the exhaust flaps were closed. And so this was something that you can't use the exhaust flaps to predict how much power it's going to generate, because that's how much power it did generate. Anyway, there's a lot of thinking through the data and saying, what do we know at what time and why? What else? Overfitting. This one's fun. This is just a generalized linear regression model, but most of you have done enough linear regression, or at least remember it from school, to see this, that an underfitted model just kind of throws something up at the data and doesn't really do a good job of predicting how things behave. A well-fit model does a good job of predicting and has some noise, but you can also overfit your model. And this is where you spend too much time concentrating on your inputs, and you start creating this model that does a real good job of predicting your inputs, but does not do well on new data. It's like building a bed. That bed is exactly the size it needs to be for that one person, but in any other situation, that's going to be a nightmare. Another one that's in the news a lot is bias. Machine learning models will reflect the bias that's in the data that's fed into them. You read a lot of things about lending companies who are trying to automate their lending algorithms, and they're finding that their lending algorithms are denying certain people loans, and you go back to their original loan officer and you find they're denying certain people loans. And so the machine learning algorithm will put out the exact same biases that are fed into it. In fact, it might multiply them. So it's important to see and understand what's going into the data and going into the model, and take steps to avoid creating models that have bias and have real human impact. So all of these things are problems that you'll run across in doing machine learning, and they're ones that I've had enough experience with dealing with that you can kind of spot them coming down the pike. So let's think about your organization. And I'm going to do an exercise here with Microsoft Teams. In the kind of top right of your Teams window, there's a thing where you can raise your hand. Do all of you see that? Have you raised your hand in a Teams meeting before? I just raised my hand. I think I raised my hand. Lower hand. All right. Michelle's got it. Connor's got it. Cool. All right. Well, raise your hand if you collect data today for your KPIs and dashboards. You've got some sort of data collection scheme going on. I'm seeing a couple of you. Cool. All right, you can put your hands down now if you'd like. Raise your hand if you think there might be hidden insights lurking within your data that you are not 100% aware of. Oh yeah. Oh yeah, we're seeing that. There's got to be something in there, right? Okay, thanks. Hands down. And now raise your hand if you have an important business decision that you repeatedly make. Do you think you could make better if you had access to those insights? There's something you wish you knew better, faster, or with more accuracy. Oh yeah. Okay. Okay. Well, with this, kind of want to introduce what we do at Marquam. And the idea here is we have this program called Machine Learning Fast Start, where we can come and work with you and brainstorm some possible machine learning projects with you using your business and your data. So we're not applying something that's one size fits all. This is for you. And come in and build a proof of concept machine learning model and tailor that model and insights for your organization. So those of you who raised your hands on this, does anybody want to speak up and talk about something at your organization you think you could possibly bring machine learning to bear on? What kind of data do you have for it? What, anybody want to be brave and speak up?
Can you say a little bit about photo processing, ways of extracting, categorizing information from photos, including OCR?
Sure. I will be the first to admit that I am not the world's biggest expert on OCR, but I have done at least one job doing photo processing where Microsoft's got this what's it called? Custom Vision. That's what it's called. Microsoft Custom Vision, where they have built models on generalized photo recognition, and then you can feed your data in it. And the nice thing about it is it requires a lot smaller sample size than you would if you had to build it from the ground up. But what ends up happening is you in Windows or something, you create a couple folders and you put some pictures of whatever categories you want into those folders and collect a few hundred to a few thousand images of those categories. And you have to hand sort the categories. And then we can bulk upload them to Custom Vision, and Custom Vision will build a model that can then recognize other things.
Thanks.
And Alex, I think the term you were looking for is computer vision.
Is it computer vision? I thought
so.
Custom Vision was their branded name. I could be wrong. Starts with a C.
Oh, you're right. It's been changed. My apologies.
All right, Custom Vision. That's what it is.
Well, thank you for sharing, Derek. Does anybody else like to come off of mute and ask about additional scenarios they're thinking about?
Well, I'll ask another one.
Sure.
What have you seen in the way of document management, document categorization? Have you seen anything there that folks are doing? We're an engineering firm, so we're essentially document creators. So, and that's all we do is pass paper and electronic files. Okay, so we get a bunch of stuff, and it's got to be categorized, it's got to be filed, storage and retrieval, search, things like that.
Mm-hmm. Would you want to be doing it on the metadata or on the file, or would you want to be doing it on the file content?
Well, both. I mean, so you get a bunch of information in. I mean, we might have hundreds of files, dropped on us all in one time. Boom, here you go. Okay. So then that has to be, sorted and categorized. Maybe opening up documents, reading them, and then we have to set or tag with metadata in somehow or another. So, I mean, just like with the photos. So, is there some way of helping us out with that process? I mean, any little bit would help.
Something that can automatically tag each of the documents. That's interesting. That's not an application I've used before, but it's something I would be interested in looking into, because there's got to be a way to do that.
So it's kind of a combination of, OCR, if it's not already there, but then to actually, read it and understand that, okay, this is a drawing of a pump station, okay, or this is a drawing of, of an office building.
Right. The technology is definitely there to do that. So, yeah, that's the sort of thing that I would need to do a little more research into what the best practices are, but that's definitely something that could be done with machine learning.
Yeah, I thought so. I was hoping so.
You open up Microsoft Word now, and you paste an image into Microsoft Word, and it uses machine learning to try to capture that picture. Usually it's like a person, wow, or something like that. But Microsoft's got that built in. So there's got to be a way to do that with document types, especially if we train it with something like 10 or 15 most common document types.
Yeah. I didn't know Word did it, but I've seen OneNote do it.
I think it's everywhere in Microsoft Office.
Well, thank you, Derek. That was a great scenario. Do you have any other questions?
That's all I have.
Okay, thanks for sharing. Would anybody else like to ask a question of maybe a scenario you're thinking about where you're curious if machine learning might be a fit? Okay, well, no worries. We'll stay on the call for a little while, but go ahead, Alex.
Oh, I just say, if this is the sort of thing you're interested in, I'm a data scientist, not a sales guy, but I know we've got Joe and Summer here on the call that are sales reps and would love to talk to you about this sort of thing. And as Joe alluded to in the beginning, Microsoft funding, and these guys are the experts at that and being able to tap Microsoft for some assistance in making this happen.
And again, just to expand on how the funding works, if you are at a large organization, the funding can be available to help you out with different parts of the project. And it can depend upon the scale of the project, but if you're at a large business, it can be anywhere between $5,000 and $20,000, which is a good chunk of money to move something along. And that might be, for example, in a project like this, getting your data into a new data repository so that it's easier to access, easier to refine. It can be other parts of the project, such as the dashboards and analytics that you want out of it. There can be a lot of different funding options available, but we're always happy to help you understand what's available to you. And I think that might be the end of the slide deck. Do you have anything else, Alex?
Thank you, everyone.
Great. Thanks for joining us on the call today, everybody. I'm going to turn off the recording.